So a homeowner might ask, well, why do Energy Star? Shouldn't we be doing that, or doesn't that happen anyways? Well, my experience is no, it doesn't. Until you actually have third-party verification and the performance testing that goes along with that, it's really hard to know whether you're achieving what we call a high-performance home. There are many builders out there who claim it, but again, until you have the third-party verification and go through the process, in my opinion, I just don't think you achieve it. Many of the builders choose to build Energy Star because of the quality control, the quality assurance that the program provides to them. They found that it minimizes and it significantly reduces callback problems over the once the home has been completed and homeowners have moved into the home. They also like the marketing aspect that Energy Star awards them to verify, to prove that they actually do build a high quality, high performance home. Okay, so to summarize what we've done to date, the main requirements are, there are 4 checklists that we have to meet, all applicable requirements defined on these checklists. The last couple of days we've looked at what's appropriate for the thermal enclosure checklist, making sure that all the air sealing had been completed, thermal bridging had been minimized, insulation had been installed correctly. The 2 other checklists are the HVAC rater checklist and the HVAC contractor checklist. Part of the inspections I've done here these last couple of days were also to look at the ducts to make sure that they had been sealed correctly. Mastic had been liberally applied on all the duct seams and joints and transitions. The appropriate insulation had been installed on the ducts, particularly in the attic area, since we won't be able to see those later once the insulation has been installed. But at the final, I'll come back and I'll look at all the ducts that are installed in the crawl space to make sure they have completed and done the work. And then the HVAC contractor themselves have their own checklist and have to meet certain requirements on that checklist where they do their own balancing of the duct airflows, of the airflows at all the registers, and just making sure then all the applicable requirements for the HVAC installation have been met to meet Energy Star. And then the last checklist is the water management checklist. Basically, the purpose of that checklist is to make sure that we control water and moisture that occurs at the interior within the home, and then moisture that occurs at the exterior. This is a builder self-verification checklist. The builder will go and he will complete it and then provide a copy of it to me, which I submit then to Energy Star. For example, on the interior, just making sure that proper materials are used in the wet areas like bathrooms, laundry areas, and making sure then the proper flashing has been installed around windows and doors to make sure that water drains away under very wet conditions. Grading around the home, proper weatherproofing, moisture proofing of the foundations. In these particular cases, we have crawl spaces, so making sure we have a vapor barrier that has been properly installed in the correct material, correct plastics or polyethylene has been used and installed down in the crawl space. So these are just a few of the items that are on the water management checklist, just to make sure that moisture is correctly handled over the course of the life of the home. So that kind of summarizes it. Then at the final, at post-construction, I will come back, or the rater will come back and perform the performance testing, a blower door test, duct blaster testing, airflow measurements for whole house ventilation, bathroom exhaust flow measurements, and final verification inspections. Those last items on the thermal enclosure checklist that I haven't seen today will be inspected at the final, like the insulation between the floor joists and the crawl space. Let's see what else, and any other air sealing like hot water heater and furnace flue penetrations through the walls. So any other details on the checklist that we had that aren't completed until the final will be looked at that time. This information is all compiled and then submitted to the HERS provider, who then processes that information and submits it to Energy Star, and then the Energy Star certificate then is awarded to the builder for this home. Okay, good morning. My name's Mike Fersoni. I'm an Energy Star rater. I provide the verification services for the Energy Star program for Silver Pit Contracting. Today we're going to look at the thermal enclosure checklist rough inspection. Basically that's going through and looking at all the applicable items on the Energy Star thermal enclosure checklist, the TEC checklist, that in regards to the kind of the 5 different categories that describe the checklist. The first category has to do with fenestrations. We have to make sure that all the windows and doors meet the minimum thermal performance requirements. The second category has to do with the insulation, making sure the insulation is properly installed. We won't look at that today. That comes the second inspection for the thermal enclosure checklist, which we'll do in a few days after the insulation has been installed. At that time, we just have to make sure that it has been installed to the ResNet grade 1 insulation level. Okay, the next area that we look at has to do with full alignment of air barriers. You know, making sure, for example, like all wall cavities, exterior wall cavities are enclosed on 6 sides. There's certain areas where that kind of thing can be problematic. For example, behind bathtubs, behind stairwells. Sometimes, which is common practice, is these areas are just overlooked. I mean, for example, the insulation will get installed, the tub will be slid in, and that 6th side, that interior side, doesn't get installed to totally enclose the insulation, which can lead to convective air problems, air moving around the insulation, in effect kind of short-circuiting the R value of the insulation. So we'll look at those details. The other thing we'll look at has to do with air sealing, making sure that all penetrations through top plates, bottom plates, through the floors, the walls, all different kinds of air infiltration pathways are sealed at this point. Then let's see, the last category has to do with reduced thermal bridging. Now, Energy Star provides a number of different options for the builder to meet that requirement. For example, using like SIP panels, using like insulated concrete forms. What Silverpick implements is the advanced framing option, where with 2x6 construction, everything's on 2-foot on centers instead of 16-inch on centers, making sure that insulation can get into the all wall corners. For example, right here, you can see how they kind of a 3-stud corner where the insulation can get all the way back into here. At intersections of interior walls to exterior walls, making sure full insulation can get into that transition. So we'll be looking at those particular items and then checking them off to make sure that we're compliant per the checklist. Again, TEC stands for Thermal Enclosure Checklist. Okay, this paper right here, it's just kind of a two-page checklist. Well, it has to do with energy efficiency. Making sure that we're achieving the highest level of performance for the home that's possible. In past years, for example, what I've noticed, I've gone in and looked at homes via my infrared camera, like during a blower door test, at post-construction, and see what's going on behind the drywall. How well is the insulation working? How well is the home air sealed? So I did these kinds of inspections pre-version 3 Energy Star and then post-version Energy Star, and we noticed a dramatic change. I mean, for example, you could see air infiltration coming into interior walls from vented attics between the top plate and the drywall, whereas now version 3 requires that top plate needs to be sealed between the top plate, that wood top plate, and the drywall, okay, to inhibit that kind of air infiltration occurring. We looked at kind of potentially air voids where insulation wasn't properly installed behind bathtubs or stairwells or similar types of areas. So again, you're ending up with what we call a high performance home, okay, making sure that you're getting full R value, the homeowner's actually getting full value for the money they're spending for their home. Okay, yeah, sure. Right now, Dan is caulking the exterior wall bottom plate to the floor. Again, that's kind of a prime area for air infiltration to work its way through that transition where kind of the floor and wall assemblies kind of come together. So that's a key requirement on the thermal enclosure checklist. So we can see, and then what Dan will do is he puts a bead down, then he'll tool that right in to make a nice seam to really make sure then we have a complete air seal there. Also, what I'll do is I'll walk the perimeter of the house just to make sure then all the advanced framing requirements are met. Again, we can see the 3-stud corner. We can see insulation gets fully back in here. We see the studs basically on, 2 foot on centers. One of the requirements is to minimize the amount of lumber that's being used. For example, Energy Star requires you have, 2 king posts, 2 jack posts on each side of a window, then you got your header. We need to make sure we have a minimum R5 insulation in the header. And they want to minimize the number of cripples. You want to make sure that you only have enough cripples in there to keep the spacing for the drywall. Okay. You can see they do a really nice job of air sealing. A lot of times, air can get into this cavity, and sometimes it'll come in via these wires and then into the box and into the house. But they do a really exceptional job of getting all of the systemic points where air infiltration will occur. At the top plate, at the wall. Let's see, any bottom plate penetrations? Don't see a whole lot. And then Dan, right now we're sealing around the window using non-expansive foam. In this particular case, there's really not much of a gap there, so he's doing a good job of caulking it. Okay, and another requirement too is we have to make sure that the drywallers seal the drywall to the wall top plates that are adjacent to vented attics. So for this particular home, the entire ceiling area has a vented attic above it. So wherever you have a wall top plate, the drywallers will come in, they'll put a good bead of caulk down, and then they'll come in with the drywall to seal that gap that can occur, that seam that can occur between that drywall and the top plate, where then to eliminate any air infiltration that can work its way through that transition. And one of the things Silverpick has implemented to try to help make sure that nothing gets overlooked, as you can see, they've spray painted the wall top plate where they want the drywall contractor to seal, just to make sure it doesn't get overlooked, just to make sure that they just don't leave it to the contractor when they're right in the middle of installation, to make sure something doesn't get overlooked. You can see another detail here, which has to do more with the HVAC checklist. Energy Star requires also specific requirements dealing with heating, ventilation, and air conditioning systems. Okay, one of them is to make sure that we do not overpressurize the bedrooms. When forced air, whether it be heating or cooling, is occurring within each bedroom. So in this particular case, to try to relieve that pressure, the HVAC contractor has installed a jumper duct. So we can see from a bedroom over here into this main living area, he's installed this jumper duct over kind of the wall top plates to connect kind of living area to this bedroom to relieve any pressure buildup in there. They have just, kind of several model types that they build out here. So they really, over the initial process, they've really dialed it in. They've tweaked it here, tweaked it there. They find what works best, what doesn't, to the point now where, their homes, I think, are, exceptional. Okay, so another area that we have to look at is to make sure the thermal alignment is done correctly, which is conventionally overlooked a lot, is what goes on behind bathtubs, behind shower stalls. And in this case, we have an insert, and you can see in advance of the insulation contractor having shown up on site and beginning his work, Silverpick is already insulated behind the tub, and then they put the 6-side air barrier on. Energy Star requires a solid, durable air barrier, which can be either rigid or it can be flexible. And in this case, Silverpick uses house wrap. I think you guys use Tyvek, is that what it is? So basically, you can see it's stapled along the top, but they put a bead of caulk to make sure that the perimeter and all the overlaps are sealed, so we have a good, complete, 100% air-sealed barrier behind the tub. One of the advantages of using like Tyvek or a house wrap type of air barrier is it stops the movement of air, but it also has a permeability to it. So if things do happen to get wet, whether that moisture is occurring because of what's going on in the restroom or the bathroom area, or something going on that occurred on the outside, this wall system still has the potential to dry to the inside and dry to the outside. Okay, so it's a good strategy. This is commonly overlooked, in today's conventional construction. Basically, what happens is they would either just slide the tub in and come back and stuff the insulation back behind there. Okay, and that 6th side never gets on there. So, for example, if you'd come back later with a infrared camera and you would look at that, you would notice all of a sudden a change in surface temperature because of the convective air currents that are moving around the insulation, dropping that R value, reducing that conductive heat transfer, or actually increasing it because of the convective air currents. Okay, so with this particular window, one of the requirements is since Silverpeck elects the performance approach for Energy Star. Energy Star offers two approaches. One is prescriptive, one is performance. In my opinion, the performance approach is the much better way to go because it allows a lot more flexibility, but then the output result also quantifies how much better the home is, say, with respect to the minimum prescriptive approach for Energy Star. So the homeowner then will know, say, we're actually this much better than what the Energy Star minimum requirements are. So one of the things that for the performance approach, we have to meet the 2009 International Energy Conservation Code requirement for windows. That requirement is a 0.35 U value, and you can see these windows via the NFRC label has a 0.32 U value. So it's a really nice window that they install here. And you can see they've done a really nice job of foaming around the window using a non-expansive foam to seal it. Where the voids are big, again, they use the foam seal, but then if it's a really tight seam, they come back and they caulk it. And they do a really nice job with the house wrap, with bending the Tyvek into the actual rough framing and making sure they have the proper exterior flashing detail for each window and door area. And again, I think Silverpeck themselves will get more into the water management checklist, which is one of the details, requirements that's called out. Okay, during the rough inspection, besides looking at all the requirements applicable to the thermal enclosure checklist, I'm also required to look at anything relevant to HVAC. Okay, for example, right up here we can see, again, this is a bedroom. We have a dedicated return. Instead of before we talked about a jumper duct, but being that the main return line, which you can see the main boot is right there in the hall, goes into the attic, runs over here into the mechanical room where the furnace will be mounted. And Energy Star requires a minimum R6 on the ducts, but per code in Durango, Colorado, we're required to have R8 up there. So it's an R8 wrap on the duct system, and you can see the HVAC contractor has done a really nice job of insulating it, making sure all the transitions, all the way to the boot, where this transition here from this duct run in the return in this bedroom up into the main trunk line. You can see that's well insulated and taped. Also in this bathroom over here, we can see the exhaust fan hard piped all the way, and it exhausts directly to the outside through the roof. The Energy Star requirement for exhaust fans, we have to make sure we measure at post-construction a flow rate of 50 CFM or better. And the fans have to be rated at 3 SON or lower. And the idea is with the SON is to make sure they're quiet enough that the homeowner will actually use the fan. I mean, a lot of times, in older homes, you'll have fans that are quite noisy, and homeowners just don't want to listen to that noise, so they don't use the fan. And it's so important to make sure that our bathroom ventilation is working correctly because of the amount of pollutants that are accumulated, amount of moisture that can be generated within the bathroom. It's really important to get those things exhausted from the house. Okay, one key area is to make sure all the floor penetrations are well sealed. For this particular home, it's a vented crawl space, so we'll have a lot of air movement within the crawl, so we want to make sure all the floor penetrations are well sealed, and then of course the floor cavities between the joists are properly insulated. And again, that's something that is inspected and verified at construction completion. So in this particular case, we can see this floor penetration where the tub drain and trap makes quite a large hole. What's common, what I've seen over the years, is this is kind of an area that's just overlooked in terms of air sealing. Okay, it's kind of the contractor, the plumbing contractor will come in after kind of a lot of the initial rough-in work has been completed, a lot of the air sealing has already been done, and they'll set the tub, cut out a big hole. In fact, they did a really nice job. It's as small as holes you can cut out to get all the plumbing in there. A lot of times I've seen giant holes, to run that trap and everything down through there, and it makes it very problematic to try to seal that area. So in this particular case, you can see it hasn't been sealed yet, but that's the next step. So I think it's really important to point that out, because that can be a significant area of air infiltration into the home, especially bringing in crawl space air, which, you know, and many times cannot be, you know, can be a polluted type of air coming into the home. Another Energy Star thermal enclosure checklist requirement is to make sure that full insulation can be installed at the transition where an interior wall comes into an exterior wall. Like in this particular case, you can see they implement ladder blocking to connect this interior wall to the, you know, to this exterior wall, and we have full cavity opening in here to allow the insulation contractor to install the full R value of the insulation. Let's see, that's a good 12 inches to the over the, so like 10 to 12 inches over the top plate. Energy Star says you have to have a minimum R21 for our climate zone over the exterior wall top plate. I mean, ideally, you know, you would like to get the full R value, but that's the requirement for Energy Star. You know, they say you at least got to have 21 on the exterior wall top plates. Okay, so again, we'll go into more of that, say Monday, when we come back. The home's been insulated. You know, we'll see the attic eave baffles installed correctly, and just go over those details that have not yet, you know, been completed. Good morning. We're here for the continuation of the Energy Star thermal enclosure checklist. As you can see, the insulation has been completed. The product that was used for this particular home is blown fiberglass. One of the requirements is to verify that the insulation has been installed per ResNet grade 1. What that means is the insulation has been installed exactly how the manufacturer recommends it be installed. There's no voids, there's no gaps, there's no compressions. The ResNet grading standard, there's grade 1, which means perfect installation. Grade 2 means there's some voids or gaps in the insulation. And grade 3 means was poorly installed. And that rating then figures into the HERS index calculation. So in this particular home, the requirement is for grade 1, and you can see there's no voids, it's perfectly installed. When you compare this kind of insulation to, say, to bad insulation, blown versus bad, bad insulation can be somewhat problematic to achieve grade 1 because of within a wall cavity you have all different kinds of obstructions. You got wires, you got plumbing lines, you got blocking, just a lot of different things within the cavity that the installer will then have to cut and fit the bad insulation around these obstructions to make sure then there are no air voids, there's no over compressions, and the bad insulation completely fits that wall cavity. And that can be difficult. But again, there are many good installers out there who do an exceptional job. But in my opinion, I think the blown fiberglass is a superior product. If we look up higher too, you can see that for this vented attic, the blocking between the trusses has been foam sealed, and cardboard wind baffles have been installed to direct the ventilated air from the soffit vents up and over the blown fiberglass that will be installed at a later time once the ceiling drywall has been installed. What can happen if the baffles and the blocking are not sealed and installed correctly is air can then move through at this lower level around the blocking and create wind washing of the insulation over time. So that blown fiberglass then will blow away on windy days. You know, that air can move that insulation away from the top plate, and then you can end up with insulation voids, and in some cases even with ice damming during the winter months. Okay, so to complete today's inspection, besides, you know, evaluating the insulation, I'll look at the final details prior to drywall, because once the drywall gets up, then basically everything that's behind the drywall we won't be able to inspect again. We won't be able to, it'll be very difficult or almost impossible to see again. So we look at final air sealing details. For example, you can see the floor penetrations have been sealed. Top plate penetrations have been sealed. Once the drywallers come in, then they'll be cutting around all these ceiling penetrations. We got the return boot here. We got a jumper duct boot there. We got a bathroom exhaust fan there. Over in this bathroom, we can see a solar tube up in that area. So once the drywall has been installed, Energy Star requires that all these ceiling penetrations be sealed, with either caulk or foam sealant. Energy Star also allows the rater and the builder to work together to allow the builder then to also self-verify certain items on the checklist. And these are specifics that I allow and work with the builder to self-verify to minimize another inspection trip and charge to the builder. So he'll come back after the drywallers and make sure all these areas have been sealed. And that's very important, just to make sure we get a really good blower door test result at the end at post-construction. Okay, we just completed the flow measurement for the ventilation air intake into the home. We measured 62 CFM. For this specific home, the ASHRAE standard 62.2 requirement is 46 CFM. So what that equates to on our April air controller is, to meet that requirement, the controller needs to be set to 45 minutes fresh air intake every hour. So that's what we adjust the April air intake to. So that's basically the measurement and setting for this particular home, for the whole house ventilation system, to meet the Energy Star requirement. Now it's up to the homeowners now. I mean, the home itself will meet the requirement easily. It's up to the homeowners then to determine, what setting they want. But what I'll do is I always mark the controller so that way they'll know, where the minimum requirement is. But again, it's up to them then to decide what they want to do. For example, in the summer months, there's no AC for this particular home. Ventilation will be kind of natural. I mean, we leave our windows open here during the summer months. So ideally, you would want to turn this off. You don't want this to be running during the summer months because that would use energy. So again, they can just turn the knob all the way to off, set it off for the remainder of the summer months. Then once fall comes around, the heating season turns on again, they would then need to, adjust the setting, turn it back on, once the furnace becomes in operation. So that's kind of, the whole house ventilation system requirement for Energy Star. Well, what it means is the goal is to build the home as airtight as possible, to conserve energy. So one question is, well then, if you build a home overly tight, you're going to have indoor air qualities. Well, the idea is that's why we have this mechanical whole house ventilation system, because the homeowners themselves now have direct control over their indoor air quality. If you don't include a whole house ventilation system, and with today's technologies on how we build home, they're inherently becoming more and more airtight. And if you don't have the whole house ventilation system, you could end up with indoor air quality problems, moisture problems on the interior. So that's why it's so important. I mean, it gives direct control to the homeowner as to what's going on with IAQ within their home. So the blower door test that I conduct is what's called a single point blower door test. Basically, I'm just measuring the airflow through the fan at a test pressure of 50 pascals. Right now, today, I mean, they're going more sophisticated, using actual, software programs where you actually measure over a range of pressure differentials, create a curve, and then from that curve, you determine what that flow rate is through the fan based upon, at 50 pascals off of that particular curve. To me, that just right now it takes a lot of extra time to set that up. By choosing a time during the day when it's really calm, you can really get an accurate measurement using the single point measurement. For Energy Star, they don't define via the performance approach a air infiltration metric that you need to meet. The idea is you want that blower door test results to be as low as possible. You want that air infiltration rate number to be as low as possible to obtain the better or the best HERS index score possible for the home. Okay, the goal with Energy Star is, you have to be equal to or less than the HERS index target for that home. The goal, though, is to get as low as HERS index as possible. So that's the reason why we want to try to make the home as airtight as possible, along with the whole house ventilation system, to be designed as efficiently as possible to achieve, a better HERS index scoring. And then now what we'll do is we'll power it up and see what we get. So with this controller, I'll ramp up the speed of the fan until the gauge tells me we've achieved a pressure differential of 50 pascals between the inside and outside of the home. So the first measurement on the gauge is 877. I need to get my other data sheet. The second measurement came in at 880. Next one came in at 878. So you can see we're pretty consistent. Yeah, there isn't a whole lot of fluctuation there. So I measured 881. Next one came in at 876. So we're all within a really good range. If you want to know, what does that mean in terms of the size of a estimated hole that this air is moving through, you know, that's probably on the order of like maybe 44 square inches. So like a hole of like 4 inches by 11 inches. So a pretty small hole compared to, you know, all the surface area of the home. And this is pretty typical. This is usually kind of the number that I will see for all the tests that I've done over the past for Tierra, for their homes. Okay, so for the blower door test results for this home, we saw flow rates of roughly between 881 CFM and a low number of 876 CFM. So that's a pretty stable number, pretty really good measurement with minimal fluctuation. So what does that mean? What does 876 CFM through the fan mean? So again, to measure the air infiltration rate, we use the fan to create a test pressure of 50 pascals depressurization between the inside and the outside of the home, and then we measure the flow rate through the fan to achieve that test pressure differential. But another useful metric is the effective leakage area. What is the actual square inches hole size that is equivalent to that kind of leakage for this particular home. And for this home, that would come in somewhere like around probably like 48 square inches. So again, we're looking at what, a hole like 5 inches by 10 inches. So again, when you look at all the surface areas to this home, you know, the air infiltration rate is equivalent to a hole about 5 inches times 10 inches. So that's pretty good. Well, the ultimate goal, building sciences, our goal is to achieve as airtight as possible. So we would love to see a number, you know, down to 1, to 0. I mean, hermetically airtight. I mean, that would be the goal. And then you have the mechanical ventilation system of the home to meet all the indoor air quality requirements for the home, to bring in the fresh air, okay? The idea is that's a balance between meeting your indoor air quality requirements and obtaining, you know, the best energy efficiency via air infiltration. You know, the goal is to do the best you can. And Tierra does a pretty good job of that. They do, over the years, they've really have spent a lot of time figuring out how to get as low of their infiltration rate as possibly they can. Okay, right now I am setting up for the duct blaster test measurement. Just a little ways off the floor. And I removed the filter. That's one of the requirements, remove the filter. And Energy Star says the filter needs to be MERV 6 or better, and this is a MERV 8, so this is a good filter. Okay, basically this gauge also is used for duct blaster testing. Then this hose will be used to go into the duct systems, and I need to get my static probe. Okay, this is a static probe. I'm going to insert this in the supply main trunk. Okay.
Now.
Okay, we're about ready to conduct the duct blaster test. The equipment's set up. All the supply and return registers are sealed off. So for the duct blaster test, there's actually two tests. One, we measure total leakage. The other test, we actually measure of that total leakage, how much of that leakage is leakage to the outside. That's the number that figures into the HERS index calculation, because again, that is, you know, heated air or cooled air that's being lost to the outside. So again, that's an energy efficiency kind of negative impact for the home. So right now we're going to conduct the total duct leakage test. Okay, so I've opened up some of the windows, opened up the crawl space. The idea is we want just all the pressures within and outside the home to be balanced. So we're just going to measure now the pressure. We're going to measure the leakage within the ducts, total duct leakage within the system, the forced air system. So I'm going to fire up the equipment and see where we're at. So the test pressure for the duct blaster test is 25 Pascal. So we're using the fan, and I'm using the controller to ramp up the speed until my gauge shows we've obtained a pressure differential between basically the fan and then or basically the room, and then the pressure within the duct system. Okay. So roughly we're right at 25 pascals. And I'm measuring 64 CFM, the metric is 130. So you can see we're well below the total duct leakage requirement. So in fact, we came in at a total duct leakage of 64. The next test we need to conduct is the leakage to outside test. Okay, for that particular test, we set everything up just like we're conducting a blower door test. Now I'm going to go around the house, close all the windows, the doors, seal off the crawl space. Again, the same similar setup that we did when we performed the blower door test. Okay, so for the duct leakage to outside test, we use a combination of the blower door setup along with the duct blaster setup. The idea here is now we're using the duct blaster to pressurize the house to 25 pascals. Before, we used the duct blaster to pressurize the duct system to 25 pascals to measure total leakage. Now we're going to use the blower door to obtain the same test pressure of 25 pascals, but we're going to pressurize the entire house. So think about, when we talk about the entire house, think about also the duct system as part of that entire house. So even though that we have ducts that run within a vented crawl space, we have the return ducts that run within a vented attic. If those ducts are completely sealed, completely tight, then those ducts, the air within those ducts are all within basically the envelope of the home, okay? The idea now is we want to measure, well, if there's leaks, what is that leakage? I mean, what are we losing to the attic? What are we losing into the crawl? Okay, so the idea is we'll use the blower door to pressurize everything to that test pressure of 25. So the pressure within the house will be the same pressure in theory within the ducts. But normally there'll be some leakage, right? So because of that leakage, we'll see a pressure drop in the duct system. So what we do then is we use the duct blaster setup to actually zero out that pressure. Okay, so we have a pressure drop now in the ducts because of the leakage. We use the duct blaster and we ramp up the speed on the controller, and then the gauge will tell us when that pressure gets to the point where it zeroes out that pressure drop that originally was occurring in the duct system via the leaks. And that flow then through the duct blaster fan is the equivalent to actually the leakage that's being lost to the outside via the duct system. So right now I'm going to ramp up this fan now to 25 pascals to pressurize the house. So we're measuring a leakage of 44 CFM. So the requirement was 65 or less. So these are really good numbers. So to summarize, per the duct blaster test protocol, our total leakage for the house for this duct system was 64, and out of that leakage, 44 CFM was leakage to outside. So those are pretty good numbers. And we're done with that. So one of the Energy Star requirements is each bathroom fan must vent 50 CFM or better. And to verify that, I use this flow hood, and this fan is actually venting 51. So even though I don't have a complete seal over the grill, I'm still achieving the minimum requirement, above the minimum requirement. So we are measuring 52. So in essence, we're compliant, but I would expect more on the order of, 70 or so. So let's go look. Let's go outside and look at that termination. See what's going on there. I think that'll be enlightening. Okay, so if you look up there, you can see there's the termination for the master bedroom bathroom exhaust fan. That fan directly, vents right out. And you can see the louvers. There's 3 louvers and only 1 really is opening. And again, this is pretty common. When they install that termination, if they pinch those louvers, they'll be just frictionally tight and they won't open. And in this case, just the 1 is opening, and so it's kind of restricting the flow. Even though we're getting to 50, I would expect more. So again, I'll point this out to Brent, and he'll look at it, and he'll probably get up there and tweak it and make sure it's running okay. So that's about it for that. Okay, one question a homeowner might ask is, why do we really need a bathroom fan? Why do we need that ventilation? For example, in this master bath, we have also a nice window. We can just open the window. Well, the answer to that question is multifold. For example, during the winter, how often would you open that window on the coldest days? The purpose of the bathroom fan is first to remove moisture that's being generated, via the shower, the tub, the sinks. Again, this is one of the highest area, or an area where the highest concentration of moisture will occur. Over the years, I've gotten phone calls from homeowners asking me, why are my windows in my master bathroom and bedroom, why are they icing up every morning I get up? And I ask them, well, how often do you use your bathroom fan to ventilate, to remove that moisture after you've taken a shower, or you've used water within the bathroom? And again, once they figure that out and they start using it, I find out, well, that problem went away. Another main problem too is that occurs within bathrooms is that they're very polluted. And studies have shown bathrooms have high concentrations of VOCs, volatile organic compounds. And these have been shown to be detrimental to our health over time. So if we're experiencing, this low level of indoor air quality within our bathrooms, and we're in our bathrooms every day, we're being exposed to that over time. What is that going to do to our health? Well, it's not going to be a benefit to our health. So they're finding out that we really need to ventilate the fan, use ventilation via the fans to get these pollutants out of the home. These VOCs, they come from the products that we use, for cleaning, the bathrooms, the hygiene products that we use. They all a lot of these products give off high concentrations of VOC, and in such a small area, those concentrations then build. So we can see today that a lot of the bath fan manufacturers, they understand this, and they're incorporating more advanced strategies on how these fans operate. For example, a lot of them have motion or occupancy sensors, so they'll always turn on when someone's in there to remove pollutants. Some of these fans will run continuously at very, very flow rates, but the idea is to remove these pollutants out of here. So Energy Star is saying at a minimum, we need to make sure that when a homeowner turns a bath fan on, that bath fan is going to at least ventilate to 50 CFM. So again, this is kind of an invisible phenomena that's going on within the home. But again, in terms of indoor air quality and durability of the home, making sure your bath fans are operating correctly are really important. So what Energy Star requires is that every bedroom, with all the doors closed, the pressure buildup within that room should be 3 pascals or less with respect to, say, the main living area center of the home. So that's what we're going to do now. The furnace is running. We're going to close all the bedroom doors. And then we'll measure the pressure in each of the bedrooms. So we'll start with the master bath. Okay, so I need to run my probe tubing out here into the hall, and then I'm going to close the door, so if you want to come inside. With the furnace running, we have both the master bath open to the bedroom, and then we have the 2 registers here in the master bath, or master bedroom itself. I'm measuring 1.5, 1.6 pascals pressure, so we're well below the 3 pascals threshold. So that's really good. And the reason being is, in Tierra's design, they have a dedicated return in all the bedrooms. So in the master bath, we can see that. That ties into the main trunk of the return. Okay, the Energy Star program, to be compliant to the requirements, a builder must meet a number of mandatory requirements. One of the requirements is the home has to score on the HERS index equal to or less than the Energy Star's HERS index target. Okay, that usually isn't a problem. I mean, Tierra and all the builders that I work with, they've done a really good job of making their homes, well more energy efficient than the target that we have to meet. But there's several other, or many more, mandatory requirements. These requirements are defined in the Energy Star checklist. There's 4 checklists. The first checklist is called the Thermal Enclosure Checklist. We'll look a little bit more about that later when we evaluate the crawl space insulation and the attic insulation. There are 2 checklists that have to do with the HVAC systems. There's one checklist specific for the HVAC contractor, and there's one checklist specific for the rater. A lot of what's done on the rater checklist has to do with just evaluating and just making sure a lot of the information that the HVAC contractor provided is accurate, that they've kind of done their job. And for the rater then to evaluate the system just to make sure it meets the requirements defined by Energy Star. The other checklist is the water management checklist. Basically, that is a checklist specific for the builders, builder self-verification. The purpose of that checklist is just to make sure that specific strategies are implemented to control moisture that occurs at the interior of the home and at the exterior of the home. So basically, the builder themselves need to check off on that checklist, make sure all the relevant applicable requirements are met, and then they sign off on it, and the rater then just collects that checklist at the end of the project and submits it to Energy Star. So right now we're going to perform one of the measurements that are required on the HVAC rater checklist. In this particular measurement, we're going to measure the duct static pressure with the furnace in operation. So right now we have the furnace. Let's see, it's kicking on. Let's just wait and see till we get air coming out of it. Okay, so for this particular test, I'm measuring the static pressure within the duct system on both the supply and the return side. The purpose of this is just to make sure that my measurements are with 110% of the HVAC contractor's measurements. The idea being is that the static pressure within the duct system is an important number in making sure the system is operating correctly. We have to have a MERV 6 or better filter. This is a MERV 8. The filter cabinet filter cabinet needs to be gasketed and airtight. And it is. So that way there's no air bypass around the filter. And one of the other requirements is that the April air, fresh air coming in, needs to first go through the filter before it goes into the house. And again, that's the design has implemented that strategy. Basically, the duct for the April air is kind of right up in there, so that fresh air would come in through the filter to the air handler and then distributed through the house. So right now we're measuring the static pressure. I'm measuring about 0.13, 0.14 inches water column pressure on the supply side. And this is the static probe. We insert it within the test ports that the HVAC contractor provided. So I'm going to put this on the return side. And I'm measuring minus 0.45. The HVAC contractor, his measurements on the supply side were 0.12 inches. I measured 0.14. On the return side, the contractor's measurements were 0.45 inches water column. I measured 0.45, so very accurate. So right now, again, there's a compilation of both Raider HVAC checklist items that I'm looking at and Raider thermal enclosure checklist items. Like, for example, here's the thermal enclosure checklist. It's a 2-page document. Most of the requirements on here I've already inspected during the rough-in period and the post-installation pre-drywall period, when I conduct inspection just to make sure all the relevant Energy Star TEC requirements are met at that time. And then at construction completion, I come back down and look at the insulation between the floor joists and a few other things. You know, I'll go in the attic and I'll look at the insulation in the attic, and yeah, there's just a few other things on here: attic hatches, weather stripping on doors, that kind of thing, just to tie it all. Usually about 50% of the requirements that are on this checklist are applicable, you know, to what's going on with this specific home. So right now I'm just going to look at the duct insulation just to make sure that everything there looks okay. So I'm going to crawl down here a little ways. So again, I can see a number of transitions directly into the main trunk here. Again, that we want our insulation to butt right into that, okay? Whereas right here, we can see exposed metal. In fact, you know, I put my hand on it and I can feel it's hot. You know, it's warm. It's you know, radiating heat into this vented crawl space. So again, the idea is we want to make sure that insulation gets installed on there correctly. So again, that's something I'll point out to Brent at Tierra, and you know, they'll have to come back and, you know, revisit, you know, all of these transitions. Yeah, I can see pretty much all of them. These little details, you know, you may think them to be, you know, just not all that important. But again, it's the little details that really all add up to really make the home what's called a high performance home. You know, a lot of the contractors don't believe it, but again, the testing and studies have shown that that's the case. And you know, after homeowners have lived in these homes for a while, I mean, their feedback is, you know, validifies that. Then another requirement is for the, and this comes on the water management checklist. Again, this is a builder verification item, is that a durable, let's see, vapor barrier is installed on the floor of the crawl space. And looking at it, again, this is a builder self-verification, so it doesn't fall within my mandate. But again, I always look at it, just point it, if it's not done right, I point it out to the builder since I'm down here. And they've done a pretty good job. I can see everything's covered. You know, it's kind of dirty down here, but I've looked at it as I was moving around. I didn't see any punctures or any gashes in it, so everything looks okay. You know, my preference would be to see it cleaner. That way we wouldn't get the, you know, the use that it's already gotten by having work done down here. Okay, the insulation specification is R49, and these insulators, they install like inch incremented yardsticks to show the depths on the trusses, the vertical truss piece. And it shows the insulation kind of around 20 inches, plus and minus a little bit, maybe 21 to 19 inches. So again, that for this insulation type, that's a good R49. One of the other Energy Star requirements is if the attic hatch is located within the conditioned crawl space, the living space, then that hatch needs to be insulated to an R10 minimum, like a rigid blue board, and to be gasketed. Well, in this particular case, the hatch is located in the garage, so that's not a mandatory requirement. So everything looks pretty good. And I can see the return duct, and I can see it's insulated all the way into the main boot. Okay, that takes care of that. Just got to go and inspect the lighting appliances, and that's about it. So, shoot pictures of the HVAC and the hot water, and just document stuff.
So you're pretty much kind of wrapping up.
Yeah, pretty much wrapping up.